Assalamu alaikum dear students. In the previous class we have actually discussed the resolution of a vector in a plane and the resolution of vector in space and their corresponding observations. Very much important topic that we have discussed in the previous class, how to resolve a vector into its corresponding components in a plane or in a space. What would be its scalar components, what would be its vector components in plane and in space, we have discussed them. And what would be the magnitude of a vector when that vector has been actually expressed in terms of its components. That was the topic that we have discussed in a resolution of vector in a plane. Now I think this is the building material for our next exercise, that is exercise 10.2, and let us have a fun with exercise 10.2. Here lies exercise 10.2, question number first. Question number first of exercise 10.2, very much important exercise as per the examination is concerned. So this is very much important. Here lies question number first. Once these concepts, your articles are clear, your definitions are clear, you can go through the exercises very easily. So let us have a fun. Here lies the question number 1. And in question number 1, we have to find the magnitude of 3 given vectors. We have 3 given vectors and we have to find their magnitude, find their length, find their modulus. And you guys know that in order to find the magnitude of a vector when it has been expressed in terms of its components, whether in a plane or in a space, so its magnitude is directly equal to the magnitude of a vector when it has been expressed in terms of its components is directly equal to the non-negative square root of sum of squares of its scalar components. So here we have a vector given vector A is equal to, what is vector A? That is I plus j plus k. Vector A, we have I plus j plus k. This is the given vector. A vector A which has been resolved not in a plane but in space, because it has its 3 scalar components, it has its 3 vector components. So Jigra, we have vector A and we have to find its magnitude. So therefore its magnitude must be equal to magnitude of A, and that's equal to, pretty simple exercise this is, only you have to be attentive and attractive. So magnitude of vector A is nothing that's equal to non-negative square root of sum of squares of its scalar components. Its scalar component along x-axis is 1, its scalar component along y-axis is 1, its scalar component along z-axis is again 1. So Jigar, its magnitude must be equal to square root of 1 square plus 1 square plus 1 square, and that must be equal to square root of 1 plus 1 plus 1, and that's equal to square root of 3. So implies magnitude of this vector A is nothing but square root of 3 units. The part first. Now lies the part second. So we have a vector B. We have vector B is equal to, which has again been resolved in a space as 2i minus 7j. It is 2i minus 7j minus 3k. This is a vector which has been resolved in space. Vector B is equal to 2i minus 7j minus 3k, and we need to find its magnitude. So therefore magnitude of vector B is again directly equal to, yes, square root of non-negative square root of sum of squares of its scalar components. So this is a vector which has been resolved again in space. Its scalar component along x-axis is 2, along y-axis is minus 7, along negative direction of y-axis, and along z-axis again minus 3. So magnitude of vector B is equal to square root of, yes, sum of squares of its scalar components. What is that? 2 square plus minus 7 square plus minus 3 square. Calculate that thing. You will directly find the magnitude of that vector B. So that's equal to square root of 2 square is 4, 7 square is 49, plus 3 square is 9. So that is equal to, implies magnitude of vector B is then equal to, yes Jigra, 49 plus 9, that is 58, 58 plus 4, yes Jigra, that is 62. So square root of 62 units must be the magnitude of vector B. You can split that 62 and by factorization, or you can keep it as it is. Magnitude of B is equal to square root of 62. Same is part C, and that's equal to vector C is equal to, yes, vector C has been expressed again in terms of its components as 1 divided by square root 3i, 1 divided by square root 3i plus 1 divided by square root 3j and minus 1 divided by square root 3k. This is the vector which has again been resolved in space, and you have to find its magnitude, and I hope you can do that quite easily, quite conveniently. So do that yourself. All about question number first of exercise 10.2. Now guys, the question number second, that is in question number second we have write two different vectors having same magnitude. We have to write two different vectors. Vectors should be different, but their magnitude should be same. Their length should be same, their modulus should be same, but they should be two different vectors, and we have to write them. We can write these vectors according to our choice, according to your choice. तो जिगरा सपोज अगर आपके पास एक वेक्टर है, सपोज I plus j, a vector resolved in plane, its corresponding components along x-axis and y-axis are scalar components 1 and 1, and vector components are I and j are 1i and 1j. और अगर आप दूसरा वेक्टर सपोज ले लोगे I minus j, so I minus j और I plus j, ऐसे दो वेक्टर्स हैं which are totally different, because here lies the addition of I plus j, here lies the subtraction of I and j. So means I plus j and I minus j are totally two different vectors, but their magnitude is obviously same. Why, Jigra? Because if you have to locate the magnitude of I plus j, what is that? Square root of 1 square plus 1 square. And what would be the magnitude of I minus j? Square root of 1 square plus minus 1 square. ये भी आएगा जिगरा square root 2, और ये भी obviously आएगा square root 2. So they are two different vectors but having same magnitude. तो यहाँ पे लिखेंगे the two different vectors having same magnitude, two different vectors having same magnitude are, हाँ जिगरा कौन से होंगे? एक I plus j और दूसरा I minus j. So I plus j and I minus j are totally two different vectors, but their magnitude is obviously same. All about question number 2. Pretty simple exercise this is, and here lies the question number 3 of that same exercise. And here we have to write two different vectors having same direction. अब दो different vectors लिख दो जिनकी direction same है. मैग्नीट्यूड डिफरेंट होना चाहिए लेकिन डायरेक्शन सेम होनी चाहिए. तो अगर आपका एक वेक्टर सपोज 2i है और अगर आपका दूसरा वेक्टर सपोज 5i है, तो 2i वेक्टर एंड 5i वेक्टर आर ऑब्वियसली टू डिफरेंट वेक्टर्स बिकॉज देयर मैग्नीट्यूड्स आर टोटली डिफरेंट. यू कैन राइट दीज वेक्टर्स अकॉर्डिंग टू योर चॉइस. सो 2i एंड 5i आर टू डिफरेंट वेक्टर्स, लेकिन इसकी भी 2i की भी वही डायरेक्शन है जो 5i की डायरेक्शन है, बिकॉज 2i एंड 5i आर टू वेक्टर्स व्हिच लाई अलोंग द पॉजिटिव डायरेक्शन ऑफ व्हाट? Positive direction of x-axis. So 2i vector and 5i vector are two different vectors having same direction. तो यहां पे लिखेंगे the vectors, the two vectors having the two different vectors having same direction. The two different vectors having same direction are, yes, 2i and 5i. तो जिगरा 2i और 5i दो different vectors होंगे क्योंकि इनका मैग्नीट्यूड डिफरेंट है, तो डिफरेंट वेक्टर्स होंगे, लेकिन इनका सेंस जो है, इनकी डायरेक्शन जो है, they both will lie along the positive direction of x-axis. So they are two different vectors but having same sense or same direction. All about question number 3. Move on to 4. क्या है जिगरा क्वेश्चन नंबर 4? Find the value of x and y so that the vectors 2i plus 3j and xi plus yj are equal. We have two given vectors and they are equal, and there we need to find the values of x and y. Here lies the question number 4 of this exercise. We have given two vectors resolved in space, and we need to, rather in plane, and we need to find the values of x and y. So given क्वेश्चन नंबर 4 में दे रखा है, given xi plus yj is equal to 2i plus 3j. 2i plus 3j. Given that two vectors which are resolved in plane because they have only two components, one along x-axis and next one along x-axis and next one along y-axis. So, but given that these two vectors are equal, when two vectors are equal, obviously their scalar components, their vector components must be equal, or their scalar components must be equal. So when their scalar components are equal, what is the scalar component of a vector on LHS? The scalar component along the x-axis, that is x, and the scalar component of this vector along x-axis is 2. The scalar component along y-axis of this vector is y. The scalar component of this vector along y-axis is 3. So obviously when two vectors are equal, their corresponding components are equal. So therefore x must be equal to 2 and y must be equal to 3 by equating the corresponding scalar components. Because when two vectors are equal, यहाँ पे आप लिख भी सकते हो, equating the corresponding scalar components, we get yes, x is equal to 2 and y is equal to 3. Because when two vectors are equal, obviously their corresponding components are equal. Now lies the question number 5 of this exercise 10.2. What is that? Find the scalar and vector components of a vector with initial point this and terminal point this. आपके पास जिगरा एक वेक्टर है जिसका इनिशियल पॉइंट है, सपोज उसको हम ट्रीट करेंगे, ले लेंगे, डिनोट करेंगे ए से, तो इसका इनिशियल पॉइंट ए है जिसके कोऑर्डिनेट्स हैं 2, 1. A is the initial point of a vector whose coordinates are 2, 1, and let B be the initial point of that vector, final point of that vector, and its coordinates are -5, 7. So you have a given vector AB whose initial point is suppose A and its coordinates are given coordinates 2, 1, and its final point we denote that by B and its coordinates are -5, 7. This is a vector, a given vector AB, and you have to locate the scalar and vector components of this vector AB. लेकिन स्केलर कंपोनेंट या वेक्टर कंपोनेंट एक वेक्टर के निकालने के लिए हमें पहले उस वेक्टर का वो वेक्टर मालूम होना चाहिए। वो वेक्टर एक्चुअली क्या है, वो किस फॉर्म में है, तो कैसे है वो वेक्टर, उसके स्केलर कंपोनेंट उसी से पता चलेंगे। तो दैट इज फर्स्ट वी नीड टू फाइंड दिस वेक्टर ए बी, क्योंकि ये वेक्टर ए बी दिया नहीं है, ये वेक्टर ए बी के इनिशियल और फाइनल पॉइंट्स दे रखे हैं क्वेश्चन में। So first we need to find this vector AB, and after that we can locate its scalar and vector components. तो हम यहाँ पे लिखेंगे, चूंकि A और B इसने मेंशन नहीं किया है क्वेश्चन में, लिहाजा लेट करेंगे। So let A of 2, 1 and B of -5, 7 be the initial and final points. Be the initial and final points of a vector AB. Let A of 2, 1 and B of -5, 7 be the initial and final points of a vector AB. We need to find the scalar and vector components of AB, but for that we must know this vector AB. So therefore सबसे पहले हम कैलकुलेट करेंगे वेक्टर AB, कंप्यूट करेंगे वेक्टर AB। तो ये वेक्टर AB किसके बराबर होगा? वेक्टर AB is any vector, and we know that any vector is equal to position vector of its final point minus position vector of its initial point. So that must be equal to position vector of B, its final point, minus position vector of A, that is its initial point. So position vector of B minus position vector of A, that's equal to position vector of B. B is a point, its coordinates are minus 5 comma 7. If its coordinates are minus 5 comma 7, we can easily locate its position vector, because if a point has its coordinates as x comma y, its position vector must be equal to xi cap plus yj cap. So similarly, if a point B has its coordinates minus 5 comma 7, obviously its position vector must be equal to minus 5i plus 7j. So it is minus 5i plus 7j, and minus times position vector of A. A is a point, its coordinates are 2 comma 1. What would be its position vector? Obviously 2i plus 1j, or 2i plus j. So implies AB vector must be equal to, yes, minus 5i plus 7j, minus से मल्टीपल कर दो, minus 2i and minus j. अब कैलकुलेट कर दो, implies तो AB वेक्टर must be equal to minus 5i minus 2i, that is obviously equal to minus 7i, plus 7j minus j, that is minus 6j. So vector AB in terms of its components must be equal to, this vector AB must be equal to, its structure must be equal to minus 7i minus 6j. When its structure is, or rather 7j minus j would be plus 6j. So it is equal to minus 7i plus 6j, because minus 5i minus 2i minus 7i plus 7j minus j, that is plus 6j. So minus 7i plus 6j would be the structure of that vector AB. But we need to find its scalar and vector components. What would be its scalar components? Yes, Jigra, minus 7 and 6. And what would be its vector components or component vectors? Minus 7i and plus 6j. तो यहाँ पर mention करेंगे the scalar components of this vector AB are, the scalar components of AB vector are, yes, what are they? minus 7 and 6. ये बन गए scalar these components without the direction. और अब vector components क्या बनेंगे? minus 7i and 6j. The vector components of AB vector are, yes, minus 7i and plus 6j. All about question number 5, that is जिसमें लोकेट करने थे एक वेक्टर के स्केलर और उसके दिस वेक्टर कंपोनेंट्स, लेकिन वो वेक्टर उस एक्सरसाइज में मेंशन नहीं था, उस क्वेश्चन में मेंशन नहीं था, उस वेक्टर के थे इनिशियल एंड टर्मिनल और फाइनल पॉइंट्स. नाउ lies the next question, and that is question number 6 of this exercise. What is this question number 6 all about? It is find the sum of the vectors A, B and C. We have to locate the sum of three vectors which have been expressed in terms of their components, which have been resolved in space. So given we have vector A which is equal to, expressed in terms of its components as I minus 2j plus k. I minus 2j plus k. We have a given vector B which has been resolved in space in terms of minus 2i plus 4j plus 5k. Minus 2i plus 4j plus 5k. We have given vector C which has again resolved in space in terms of its components as I minus 6j minus 7k. I minus 6j minus 7k. These are the three given vectors, and directly we have to find their sum. Therefore their sum, तो उनका sum that's equal to A vector plus B vector plus C vector किसके बराबर आएगा जिगरा? A का अपना वैल्यू पुट कर दो, that is I minus 2j plus k. प्लस बी का अपना वैल्यू पुट कर दो, दैट इज -2i, yes, +4j and +5k, that is +5k, और प्लस सी वेक्टर का अपना वैल्यू पुट कर दो, दैट इज i -6j -7k. तो implies a vector plus b vector plus c vector must be equal. Yes, Jigra. I -2i plus I plus I is 2i. 2i minus 2i, that is 0i. So its component along the positive x-axis is 0, means at the origin. Yes, -2j plus 4j minus 6j minus 2j, that is -8k minus 8j plus 4j, that is -4j. Yes, plus k plus 5k, that is 6k minus 7k, that is -k. So this would be the sum a plus b plus c, 0i minus 4j minus k. All about question number 6. Pretty simple question is there. Very much simple exercise this is. Now move on to the next, and that is question number 7 of this exercise. And what is this question number 7 all about? It is find the unit vector in the direction of vector A is equal to I plus j plus 2k. We have a given vector and we have to locate the unit vector along the direction of that vector. So given in question number 7, given A vector is equal to I, given A vector is equal to I plus j plus 2k, I plus j plus 2k. Very much important as far as your examination is concerned. These types of questions are frequently asked in question papers. So Jigar, given A vector is equal to I plus j plus 2k. This is a given vector A which has been resolved in space, as it is scalar components are 1, 1 and 2, but we need to find the unit vector along the direction of that vector. यानी इसी वेक्टर के along जो हमें चाहिए एक यूनिट वेक्टर. तो हमने पढ़ा है अगर v आपके पास एक वेक्टर है तो आपको चाहिए v कैप, यानी यूनिट वेक्टर along the direction of any proper vector किसके बराबर होता है? पढ़ा है हमने जिगरा 1 divided by magnitude of vector v into vector v. इसी वेक्टर v को डिवाइड कर दो इसी वेक्टर v के मैग्नीट्यूड से, तो you will locate the unit vector, you will locate the direction of that vector. So means you can locate the unit vector along the direction of that proper vector v. So आपके पास अभी वेक्टर a है I plus j plus 2k. You need to find the unit vector along the direction of that vector. तो क्या आएगा? The unit vector along the direction of vector A is equal to, वेक्टर ए के अलॉन्ग जो यूनिट वेक्टर होगा वो किसके बराबर होगा? पहले डिनोट कैसे होगा? ए कैप. वेरी गुड. एंड दैट्स इक्वल टू ए कैप विच इज इक्वल किसके बराबर आएगा? 1 डिवाइडेड बाय मैग्नीट्यूड ऑफ वेक्टर ए इनटू वेक्टर ए, and that's equal to 1 divided by magnitude of vector A. A is a vector which has been resolved in space in terms of its components. So when a vector has been expressed in terms of its components, what would be its magnitude? Non-negative square root of sum of squares of its scalar components. So non-negative square root of scalar components are 1. So 1 square plus यहाँ पे भी 1, तो again 1 square plus 2, तो plus 2 square into vector A. What is that? I plus j plus 2k. So implies a cap unit vector along the direction of proper vector A is equal to 1 divided by square root of 1 square 1, 1 square 1, 2 square 4, 4 plus 2, that will give us square root of 6. So 1 divided by square root of 6 into I cap plus j cap plus 2k cap, or दिस कैन बी रिटन एज a कैप इज इक्वल टू 1 बाई स्क्वायर रूट 6 से मल्टीपल कर दो हर किसी कंपोनेंट को, तो क्या आएगा जिगरा 1 डिवाइडेड बाई स्क्वायर रूट 6 i प्लस 1 डिवाइडेड बाई स्क्वायर रूट 6 j प्लस 2 डिवाइडेड बाई स्क्वायर रूट 6 इंटू k. This vector 1 by square root 6i plus 1 by square root 6j plus 2 by square root 6k would be nothing but the unit vector along the direction of proper vector a, which is equal to I plus j plus 2k. You can verify this result. How? Actually this is unit vector. तो unit vector का magnitude क्या होगा? 1. इस वेक्टर का मैग्नीट्यूड लोकेट कर दो. यू कैन फाइंड इट इजीली. नॉन नेगेटिव स्क्वायर रूट ऑफ सम ऑफ स्क्वायर्स ऑफ इट्स स्केलर कंपोनेंट्स. तो जब आप यहां पे करोगे नॉन नेगेटिव स्क्वायर रूट ऑफ सम ऑफ इट्स स्केलर कंपोनेंट्स, दैट विल डेफिनेटली कम आउट टू बी 1. वो 1 आएगा. आप चेक कर सकते हो, चेक कर लेना जिगरा. सो दैट मस्ट बी द यूनिट वेक्टर अलोंग द डायरेक्शन ऑफ प्रॉपर वेक्टर ए. नाउ लाइज अनदर क्वेश्चन. Now we have question number 8, and in that question number 8 we have to again find the unit vector along the direction of vector PQ, but P its initial point and Q its final point are given. So the initial and final points of a vector are the initial and final points of a vector. The initial and final points of a vector PQ are, yes, P of 1, 2, 3 and Q of 4, 5, 6. We have a vector PQ here. Its initial point is P, which has its coordinates as 1, 2, 3. And its final point is Q, and the coordinates of Q are 4, 5, 6. Since its initial point is P, its final point is Q, obviously its sense, its direction must be from P to Q. So we need to find the unit vector along the direction of that vector PQ. So unit vector along the direction of that vector निकालने के लिए हमें पहले चाहिए वेक्टर PQ. जो PQ वेक्टर का स्ट्रक्चर अभी मालूम नहीं है, PQ वेक्टर के इनिशियल और फाइनल पॉइंट्स के कोऑर्डिनेट्स मालूम है, तो हमें पहले चाहिए PQ वेक्टर, दैट इज इट स्ट्रक्चर, और बाद में निकाल सकते हैं इस PQ के अलोंग यूनिट वेक्टर. तो सबसे पहले हम कैलकुलेट करेंगे PQ वेक्टर. Therefore PQ वेक्टर इज इक्वल, PQ वेक्टर इज एनी वेक्टर, और एनी वेक्टर किसके बराबर होगा? मैंने जब वो टॉपिक पढ़ाया था कि वेक्टर इन टर्म्स ऑफ पोजीशन वेक्टर्स ऑफ इट्स इनिशियल एंड फाइनल पॉइंट्स, मैंने कहा था जिगरा वहां पे कि ये बहुत इंपॉर्टेंट है, क्योंकि आगे एक्सरसाइजेस में या आगे कंसेप्ट्स में ये हर बार हम यूज करेंगे कि एनी वेक्टर किसके बराबर होता है. तो एनी वेक्टर इज PQ वेक्टर किसके बराबर होगा? पोजीशन वेक्टर ऑफ इट्स फाइनल पॉइंट माइनस पोजीशन वेक्टर ऑफ इट्स इनिशियल पॉइंट. सो दैट वुड बी इक्वल टू पोजीशन वेक्टर ऑफ Q माइनस पोजीशन वेक्टर ऑफ point P. So that's equal position vector of Q. Q is a point, its coordinates are 4, 5, 6. What would be the position vector? Obviously 4i plus 5j plus 6k. X coordinate के साथ I cap, Y coordinate के साथ J cap, Z coordinate के साथ K cap, फिर बाद में addition, and there you will locate the position vector of a point if its coordinates are given. So position vector of Q, that is would be 4i plus 5j plus 6k. Position vector of P, the coordinates of point P are 1, 2 and 3. What would be the position vector? Minus times position vector of P, that is equal to I plus 2j plus 3k. So implies PQ vector is then equal to, शाबाश जिगरा, 4i minus I, that is 3i, 5j minus 2j, that is again plus 3j, or 6k minus 3k, that is again plus 3k. So the vector PQ has its structure as 3i plus 3j plus 3k. यानी ये वेक्टर जो होगा ये होगा 3i plus 3j plus 3k, इसका स्ट्रक्चर होगा. That is its components, scalar components along positive x-axis, y-axis and z-axis would be 3, 3 and 3. Now you have to locate the यूनिट वेक्टर अलोंग द डायरेक्शन ऑफ वेक्टर PQ. तो कैसे आएगा? PQ वेक्टर डिवाइडेड बाय इट्स magnitude or 1 divided by magnitude of PQ into vector PQ. So therefore unit vector along the direction of PQ vector, unit vector along the direction of PQ vector किसके बराबर आएगा जिगरा? That would be denoted by PQ cap. Unit vector along the direction of PQ would be denoted by PQ cap, PQ hat, PQ circumflex. जैसे हमने यूनिट वेक्टर की डेफिनेशन में पढ़ा था जिगरा कि इसको कैप भी कहते हैं, इसको हैट भी कहते हैं, इसको सर्कमफ्लेक्स भी कहते हैं. सो दैट्स इक्वल टू PQ कैप किसके बराबर आएगा? 1 डिवाइडेड बाय मैग्नीट्यूड ऑफ वेक्टर PQ इनटू वेक्टर PQ. And that must be equal 1 divided by magnitude of PQ. PQ is a vector that has been expressed in terms of its components. When a vector has been expressed in terms of its components and we have to find its magnitude, what would be its magnitude? Nothing else, non-negative square root of sum of squares of its scalar components. So that's equal to 1 divided by non-negative square root of scalar components are 3, 3 and 3. So obviously this will come out to be 3 square plus 3 square plus 3 square. So into vector PQ, that is 3i plus 3j plus 3k. So implies PQ cap unit vector along the direction of vector PQ is directly equal to 1 divided by square root of 9 plus 9 plus 9, that is 27. 9 plus 9, 18, 18 plus 9, that is 27 into 3i plus 3j plus 3k. Or this can be written as, implies PQ cap must be equal 1 divided by square root of 27. Square root of 27 को जिगरा लिख सकते हैं square root of 3 into 3 into 3, because 3 3s are 9, 3s are 27, and that will come out to be 3 square root of 3 square into 3, क्योंकि दो बार मल्टीपल है तो स्क्वायर आएगा, into 3, and that's equal, इस 3 का स्क्वायर है, स्क्वायर रूट है, so they will cancel out, and obviously 3 बाहर आएगा तो अंदर स्क्वायर रूट में एक और 3 बचेगा. तो instead of square root of 27 we can write 3 square root 3. So this is equal to 1 divided by 3 square root 3 into 3i plus 3j plus 3k, or PQ cap must be equal to 1 divided by 3 square root 3 से अंदर मल्टीपल कर दो तो क्या आएगा जिगरा? 3 कैंसल, 3 कैंसल, 3 कैंसल, तो बचेगा 1 divided by square root 3i, 1 divided by square root 3i plus 1 divided by square root 3j plus 1 divided by square root 3k. This would be the unit vector along the direction of vector PQ whose initial point P and final point Q were given, जो दिए हुए थे, जिनके कोऑर्डिनेट्स दे रखे थे, और हमने पहले वेक्टर PQ को निकाला by applying position vector of its final point minus position vector of its initial point, और उसके बाद निकाला unit vector 1 divided by magnitude of that vector into that vector. So that's all about question number 8 of this exercise, and I think this would be enough for this class, and the remaining question of this exercise we will do that in the next class. So till then, Khuda Hafiz.